MMSD.
All right, everybody. If you've never been here before, welcome to Sector67. We do these monthly like show and tell style meetings. So we got a couple of people to share some projects that they're working on tonight. And then if you're interested in a tour, I can give it folks a tour of the shop. Then I imagine everyone voted already. But if you haven't voted, you can leave right now and go vote. It'll be much better use of your time. So get that out of the way. Let's see, I got this thing running like it's supposed to be. So we'll do quick talks. The other thing I was gonna mention real quick, if any of you guys have kids or know people with kids, there's Science Expeditions is free on campus Friday through Sunday. I'll be over there at the Discovery Building and the Institute or the Health Science Learning Center on Sunday. But they've got a whole bunch of buildings. You don't have to be a kid to go to be clear. Open to anybody. But a ton of the buildings on campus are open. This is kind of a reincarnation of, if anybody remembers, Engineering Expo used to be much bigger than it is now. This is kind of coming back to be a lot bigger than it used to be. So anyway, if you're interested in, a lot of the buildings are on campus, a lot of the labs, a lot of the groups are open doing exhibits and stuff. A lot of interactive things throughout the day. Their schedule and timetable, despite their best efforts, leaves a little bit desired. So you do have to kind of like poke through to try and understand what they're telling you is open or not open at different times. But at any rate, something to check out. It's called Science Expeditions. It's this science festival in the fall and Science Expeditions in spring. So if you run across Science Festival, it's a different thing, but it's all branded similar because it's all through the Institute for Discovery. So at any rate, check that out. It's a cool event, mainly because I'm there, but it's also cool because there's lots of other things going on as well. So without further ado, you want to take it away?
Yes. Howdy, y'all. I got a dumb one for you. So I've had this idea rather in my brain for, I don't know, like a year, maybe or two. What if you had a clock that you, whenever it wanted to display the numbers, it had a roll of dice, and those dice were the actual digits that were being displayed to you for like what time it currently was. So I ended up making it. Here's it's on the podium there, and I'll set it up after the talks or whatever over there, so you can see it like actually like flipping in person. It's pretty obnoxious. Yeah, so you have these I give it like L or whatever for a large corner. Yeah. So you have like these three pods. It's a D12. It's a 12-hour clock, just to make it somewhat simpler.
Hang on. Oh, you're good. I guess it's no. See, I knew I was forgetting something.
Oh,
don't worry. We won't make you start all over
Yes,
from the beginning.
I gave you the.
It's just Jacob and the rest of the internet. So. All right.
All right.
Just marveling at the idea of a laser pointer, and all of a sudden realize.
I still want to talk about it first. I just want my laser pointer. Yeah. So 12-hour clock. So trying to make it a little bit simpler. So I'm not trying to have to like print or get a D24 or whatever. D6 for the tens place of the minutes. The 6 is used as the 0. And then a D10 for the ones place of the minutes. Conveniently, D10s actually usually come starting at 0. So it's not 1 through 10. It's usually 0 through 9. So it already was like the same form of what I wanted. And then because this is like prototype version 1, I don't have like a panel or anything to like cover up the back. I just have it all exposed. Quick little video demo. Like I said, after this, I'll set it up over there. Yeah, it literally has to. Sometimes it's really fast about it. Sometimes it is not. Generally, it doesn't need to roll every single pod right for every single minute. One usually only advances by 1 at a time, usually. And so it only needs to usually run the ones place. Every once in a while, run the 10th place, and then once in an hour, it actually runs the hours place. It's also a little bit more tolerant. Instead of having to roll for the exact number of the ones place, if it rolls for the number, the target number or the target number plus 1, both are acceptable. So that way it's not just constantly rolling. So instead of being a 1 in 10 chance, it's really closer to a 1 in 5. I don't know how fair the dice roll is. I have not measured. Don't really care. It does cycle through numbers. That's good enough for me. So because I have it dark, and then I can take the shell off later too. But with the false color of the CAD, it's a little bit easier to see like all the pieces that are there. So there's the shell that just kind of like closes everything. So underneath, I'll use the laser pointer for people online. So there's this is just a camera, which is a little 2 megapixel camera. And then it's facing mirrors. So these are all little mirrors angled up. So it actually never sees the top of the dice. It only ever sees the bottom of the dice. And so whenever it's looking for a target number, it knows what the opposing side is and is looking for that opposing side to get what it wants. It does have a ability to rotate the die. There is a flaw in the logic that I have not cared to fix. That it doesn't rotate it correctly. But the intent is that after it has gotten the appropriate number that it wants to show you, then it would rotate so that way you're looking onto it and like the number is being nicely displayed. You're not looking at like an upside down number or like not 90 degrees off. Like I said, there's a bit of a bug in there and I just didn't get around to fixing it. That. And then on the back, there's kind of like this little plunger mechanism. So this is a cross-section view of the little pods that are in there. And you can see that there is this little like it's just a push-pull solenoid. So it just pulls down on the arm, it pivots around the pivot point and just flicks the dice up. Likewise, this is where the mirror is. And so it's just this is a little glass panel underneath is what it is looking through. So what does the camera see? It sees lots of JPEG artifacts. So I did this on ESP32, which is a very RAM constrained device. One, you do need to have an ESP32 that has the PSRAM like module like built into it. And then to get the camera to like work reasonably well, you have to keep it in like JPEG mode. Hence all the artifacting, other than the fact that it's a very dim environment, so obviously you get all that. But yeah, so I have a bunch of orange LEDs. I just had a bunch laying around as one does. So I decided to use those as my illuminators. And then I effectively just, convert I think I pull like the red channel or whatever as my quick conversion to grayscale. Since it's just not, the LED isn't like multi-spectral, like you just pull one channel, you get about as much information you're gonna get. So we crop out the dice that we're looking for, where they are, and then we start doing a little bit of vision processing. So we have the raw image, grayscale. We do some thresholding, and then there's just like a little bit of logic of basically what is the largest continuous blob in the middle of the screen, and that's how I filter all the other things. Because when you do that threshold, you'll get other things that will come through. So this gives you a really clean template to work with. And then I do a weird thing. That's what I'm actually matching off of. What in the world is that thing over there? So I didn't know about this before starting this project, but these are what's called a polar transform. So if you imagine, what if we took like scissors and we kind of cut our image along the side and then we unwrapped it. So then you would get something that would look kind of something on like the right side if you kind of start to correct your distortions. And this has some really interesting properties for matching. Yeah, I'll talk about that in a second. So first off, this makes a pretty small image for my template for when I'm storing it. I could be really clever with like packing bits into the bytes because I only have the grayscale image, right? Or I translate to a black and white. I'm not doing that too clever on that. But effectively, all of my images stored, all of my templates, like 40K of storage. Again, ESP32 has megs of flash storage, so good to be good. But the really cool property of polar transformation is that as long as I can get my image and template reasonably like centered, like they both roughly the same center point, any rotation of the die in any of my image is really a translation on the x-axis. If I have a little visualization, so you can see as I slide into a x transform of the image, it will line up really well at certain points. And so that tells me what the rotation of my dice is. Like I said, it only kind of matters because my rotation of my motors is kind of buggy, but it does know what the angle is supposed to be. It just doesn't do a good job to get it there. Yeah, like I said, I didn't know about that before doing this project. Hardware review for the nerds. So like I said, it's ESP32, a little 2 megapixel camera. I thought it'd be kind of fun to do this off of USB-C power delivery. So there's a USB-C cable like you can plug into the back, and like your fancy usually battery packs that have power delivery on them, your power delivery like wallets. it will negotiate a 12-volt supply for itself off of that. And then it uses that to run the actual solenoids. And then I have a step down to 5 volts for the servos. My controller and my controller itself just has it steps still down to 3.3. The flippers are those push-pull solenoids. I've never actually used those in a project before, so it's just kind of fun to have an excuse to use them. And then continuous rotation servos aren't necessarily like the best thing to use, but they're really, really simple. It's a very small motor package, a high torque motor, really easy to run. Basically, you can set, talk to it as if it's a normal servo, except that instead of saying go to 45 degrees, you can, but you basically say go to 0, go to 180. Its stop is gone, so it will just kind of keep rotating forever. So whenever it doesn't, stop at any point. But you can basically say go left or right, and you'll have plenty of torque and like some, the itsy bitsy. So I just use some of those projects just because I had a couple laying around. They're pretty easy to use. I played with a couple of flipper designs. This is where you're good at physics. You probably would have got the second design faster. First one, like you can see, like it gets up, but it doesn't do that much. Depending on where you get much more dramatic power, so the ones in there is closer variants of what that second flipper was, just kind of like repackaged for spacing. I cheated. So vision's hard, especially when you're not actually using a vision library. So like I said before, I do that thresholding, and then like, what's the biggest continuous block of the setting? Because that gets rid of a lot of extra artifacts. To do stuff like where I have like a 10 where it has 2 digits, like how do I find the second digit of that? Well, if I file away a little channel between the two and then I paint through it, it's one continuous blob. And this was really a big thing to fix this particular issue. So it's a single point like light source for each dice. And so depending on the rotation of the dice compared to where that light source is, you can get these really big glare lines. And so trying to be like, all right, like I've got a, maybe I have a 6, and I need to look for like that, underline of discriminant of do I have a 6 or do I have a 9? And I have to like also filter around and filter out any extra noise with these big lines. Kind of was starting to get a little hard, and I'm like, you know what? It's cheap. So yeah, I took a file to it, made it way easier. Otherwise, yeah, so I was originally really entertained by the idea of this being really annoying. It's really annoying. You can only like practically run it in a group for a little while before people like, please turn it off. I initially had electromechanical relays that actually like allow the USB32 to fire the solenoids. So you had like a definitive click, click, click every time they fired. The really, solid state relays exist, MOSFETs. You could switch the dice for like foam or rubber. That would probably, you don't want to be clinking against the glass or whatever. With the solenoids themselves, one, if you put like a kind of a cushion end stop on them as the arm finishes traveling, that would deaden it a lot. You also can play with the actuation timing instead of being like, let's say that it takes 100 milliseconds for it to go the full travel. Well, what if you fired for 80 milliseconds and you stop powering it? It's got a little spring that will start pushing it back. So really it'll start decelerating. And so by the time it hits its end stop, it might be going pretty slow, but still have most of the flipping power. So you can play with that. Servos aren't the quietest things. The gears in them are, make a bit of a noise. So other motors probably could make it a little quieter. So maybe you could tolerate getting a room with this thing constantly operating. Another improvement that'd be nice. Every time it boots up, it has to get the time from the internet because it doesn't have a built-in like real-time clock module that actually keeps track of time when power is pulled. So every time it boots up, I literally have it connect to Wi-Fi and grab time from the internet. So like a little clock module, they're not that complicated. They're not expensive at all. Would be nice though to keep the time offline. And then when if you see it later, you'll kind of see that the dice are very recessed into the pit. It'd be nice if they're a lot more prominently displayed. And so I think there's some things you can play with the flipper design itself to kind of push them up a little bit higher. Definitely some lessons learned. I should not have done this on HP32. I kind of jumped to it straight because I was like, that seems reasonable. It can do the thing that I want to do. I don't need this big old Raspberry Pi, whatever. But debugging a camera on an embedded system really sucks. The ESP32 at least has Wi-Fi, so I can like have it like spin up like little web pages that I can go and it'll like drop me the image. But that's really finicky, especially with the memory constraints that I have, with how much RAM I have. If I was using ESP32 or sorry, Raspberry Pi, I literally could be like save as like a PNG to disk, and I could open up and get and go like look at the specific pixel values, and that would have been a way easier way to have done it. I also it kept crashing early on. It won't really give you a good reason why it's crashing. It'll just be like, instruction error and like load fail. You're like, what? It blew the stack, but doesn't have a good way to like tell you that that's what actually happened. So as I was trying to figure out how to even get like the PSRAM like module like properly enabled to get the camera to actually load it there as opposed to the direct system RAM. That was just like a day of frustration. Yeah, I had everything built in pieces. And it was like, oh, I have like my little test for this and my test for this, and I just got to put them all together. How hard could that be, right? I've got it, all figured out. Yeah, that was the longest part out. Obviously, is the actual final integration. Even though you think that you can avoid it, and then cameras, like I said, cheap. It makes the vision a lot simpler, especially if you're not using an actual vision library. Like I said, this is a template match. It's not. It doesn't know what numbers are. It doesn't know whatever. So, trying to give it the simplest data for it to process. Otherwise, I think that's it. Yeah. Any questions?
What CAD did you use?
Fusion 360.
Nobody else is gonna quiz him. Come on.
All right.
So I'm curious what your design is hiding the dice. You talked about like, okay, maybe raise that up, but did you consider like mirrors or making the
Yeah, so one of the other thoughts that I had, I like the idea of you directly being able to see the dice, but something that I initially was looking at, or and it's still like an option, is just kind of like a mirror on the top angle, so you can like look from the top or like from the side and see down to the top. I think probably some mix in both is probably a better answer. So that way you can see it like at an angle, from a distance, but still have like that dice like more prominently displayed. Just
I think it
looks
would
cool to
be
see.
the mirror image, right? So that
Yeah.
reverse the value.
Yes, it's that-
Right, reverse it. Maybe write some new dice that are backwards.
Yeah. Are you in mirror mode or not?
So, because I know the 12 doesn't spin, it's only on the hour, right? But how have you tried, like, what's the longest it takes to get to the right value?
I've had to take more than a couple minutes.
By the time it gets to the die, does it have to do it again? Because
Yeah, so the logic on there is pretty simple in that it doesn't have an interrupt of like, have I taken too long? The only interrupt that it has is have I flipped three times and I keep seeing the same number? The way the flippers and like because the motor for being able to turn, it sometimes can bind itself up. And so if it sees the same number three times, it'll kind of like wait a little bit to unbind itself. That's the only smartness, that unbind logic.
But you mentioned that it can be off by one digit. Is that to deal with that time issue? Like,
That is so that way you flipping a D10 every minute to try to get the right time. Sometimes it takes you more than a minute to get the right time. So now if you only have to be the right number or the right number plus one, it makes it a little easier to get the right thing and the right time. Yeah.
Well, when he launched the Kickstarter, you gotta do one as a joke, it's a stopwatch, so it's trying to run constantly at all.
Yeah.
Clearly, that's some people buy that one. Alright, yep, last one.
What's the programming environment like in Madison 32?
So it actually is pretty cool. This is part of why I just kind of default to them in that the ESP32 has, so if you are using Espressos like I guess RTOS or whatever, it has like a full like C library that provides a lot of things that look like they're from a real OS. So I actually did this in Rust, but I can use like, if I want to, I can use something that looks almost like programming on a desktop computer. I can open sockets as if sockets are a real thing. I can open files as if files are a real thing. And the ESP32, the RTOS can make it look like they actually exist. But then you can also be like, turn this GPOI, high or whatever. So it's actually pretty sweet.
White market is facing its biggest ever drive. So
Thank you.
Get on.
See them here. Audio suggestions. Hello, I'm Bob, and I've been a member since 2011. What I'm going to talk about is the Madison Metro Sewerage District sign that I refurbished. So, this is a sign that was built in the 90s-ish, and it demonstrates the path that our waste takes as it goes through the different pipes and tanks to get cleaned and redistributed to the streams and fertilizers. And the sign was originally put up at the sewerage district plant. And then after a while, it got taken down and stored somewhere for a really long time. And somebody thought, hey, it would be cool to put this up in the public market. And the reason for that is because the sewerage district is kind of in charge of doing the restrooms at the new public market. So they had the sign, they thought it'd be cool. So I took a look at it and figured these are the things that need to be updated. The lights don't work, the motors don't work. There's a whole bunch of weird things going on with the clear acrylic. The content is out of date. The sign was this thick, like this deep, because it used components that were available in the 90s. And some of the parts had just needed refurbishing. So you can see in the top right image, they used some adhesive that yellowed over time. And so it had oozed and it needed replacing. And 270,000 Dane County residents is no longer correct. And then in the bottom right, it was rope lights that they used for all of the pipes. And most of the lights had burned out and yellowed, and it just didn't work. And then in the left image, you can see some of the films had just disintegrated. And so it just needed work. So I redesigned everything. I should mention, I started looking at this sign, I think it was in September or October. And I looked at it, put together a quote, and told them in early October that I could start immediately and have it done by the end of December. And I didn't hear back until January. So
Did they hold you to December?
no, they did not. And in fact, since this is associated with the public market, they were like, oh, there's no deadline. So that was good news. Right, so I put together the electronics, which is completely redone. Like I removed anything that carried an electron out of this thing and replaced it with my own stuff. So there's the power comes in, it's just AC power, and it goes to a power supply which has 5 volts and 12 volts. It also has 24, but I don't use that. And then that 5 volts goes to the LED strings, which are WS2812B strings, so they're individually addressable. Everything's controlled by a TNC 4.0. And there's a motion sensor which turns it all on. And then there's also 3 relays which turn on the 2 motors and the backlighting. So I picked AC motors because they are probably the most reliable and long-lasting of a motor choice. And I wanted this thing to last a really long time without being replaced. So these are the actual components. We've got the TNC is number 2, and it sits on top of the adapter board, which is number 1. And this adapter has a buffer in it, which ends up being important later in the story. But it also breaks out all of the 8 pins that drive the LED segments. And for the LED segments, I used a combination of just lines, which are for the pipe parts, and then these arrays, which are 8 by 8, but they're not like a normal grid. They weave back and forth. So the math ends up being really weird when you're trying to do like something that goes from a bubble that goes from the bottom to the top, because it goes like 0, 15, 16, 31, 32. Like it's weird math. And then in the bottom right is the motor. Then number 7 is the microwave motion sensor, which these things are surprisingly cool. So basically this thing just sits behind all of the electronics. Like it's not visible at all, and it's sensitive for like a few meters, and it detects motion really well. So I could just stand there and watch the LED that I had connected to the sensor, and it would, like, if I moved, then it would turn on, and then a couple seconds later it would turn off, and then I could move again and it would turn on, and it was 100% reliable. So way better than capacitive sensing or photo detectors or IR, like a camera. Like it was just 100% reliable. It was great. And then I have the 3 relay boards and the power supply.
Is the microwave, you said it's behind electronics, it's not actually, there's nothing visible.
There is nothing
Yeah,
visible.
It goes through walls.
Yeah.
Pretty cool.
So it's picking up any physical movement, or like because you're a human, your capacity. So if threw a ball in front of it, would set it off.
It should, yes. As a bag of water that reflects 2.4 gigahertz really well, the microwave picks it up really like better than it would a ball, but it should detect a ball as well. So it's,
They have some, are they 20? There's like 25 gigahertz plus too.
oh really?
Yeah, there's some crazy ones that detect heartbeats. So you can detect living humans versus dead humans, or like living things in the space versus. Yeah, it's fun.
Nice. Well, a dead thing wouldn't be moving, and this detects motion.
Oh, but you can have it stick.
Anyway, so this is the inside of the sign. After I have removed a lot of the previous electronics that you already saw, and there's a lot going on in here. So they had painted with flat paint to get a lot of the lights to not shine through in parts they didn't want shining through. And then they also did a lot of layers of films to either like spread it out or dim it or color it. So like the MetroGrow tank in the bottom has a green film, and then other places will have like a grayish bluish film. But they were working with rope light, so they only had one color to work with. But they used all kinds of different adhesives and glues and sticky things, and it was a pain to scrape off and get out of there. So the original sign had this this white piece of acrylic or ABS, I don't remember which, it was acrylic, that had like some tape that showed where each of the strands goes. You can see it on this image in the bottom right. You can see where they had taped. And then they also used zip ties to hold the rope light in place. So I just took that whole white piece and removed the rope light and reused the white piece because it mapped out where all the strands and all the tanks were. And I just put my own strands and matrices in place, and then used my own zip ties because 30-year-old zip ties just fall apart when you touch them. And this is the back of it. So it's pretty complicated. There's a lot of wires going everywhere. But you can see in the top right is the power supply. And then there's this black and red wire that kind of arcs around the outside. That's the 5-volt supply. And I just figured all I need to do is like use some wire cutters and pull a little bit of the wire insulation apart, and then I can just solder something onto that basically bus. And the teensy is this. No, whatever. The teensy is right here. How did we do the
L for laser.
oh
Learn a new thing, right? Maybe you might have to drop out of drawing mode.
Oh,
Get into red X to the left.
okay.
Right.
No. All right. Well, anyway, the teensy is up there. And then there's some relay boards, and we've got holes for where the motors are going to be right there and there. And you can see the motors just hanging right now because I haven't figured out how to attach them. And here is the microwave sensor. So it's just in the middle-ish. Yeah, so this was a huge pain to solder and wire. Took a long time. I can't move to the next slide.
They click in or did. But well. Oh, there were arrows next to it. So up through the top of the cursor. I don't know. No, there you go. Jesus.
Yeah, there we go.
And things.
Okay, so I've got the electronics done, and now I can put them in place and see how it actually looks. And that's just green. It looks pretty awesome. I was excited about that. And now we're actually like experimenting with the colors that I have available and what kind of treatment I can use to diffuse the light. Because if you look in the bottom tanks, there's no diffuser at all. It's just the LEDs and it looks like crap. And then up higher, I've got the original diffusers and gels that were used. And that looks better. I'm still not super happy with it. And then I experimented with just paper to see what would happen with the paper. And I also, the rope lights are okay, but they didn't actually illuminate the tanks. They only illuminated the pipes. So I wanted to do stuff with the tanks. And because I had an LED matrix, that meant I could do like bubbles floating up or particles of poop floating down. And so I experimented with that. And in this iteration, I did a 1 pixel bubble. And what I found pretty quickly was that you couldn't differentiate it when it was diffused. It just wasn't big enough. How do I make the drawing go away? Whatever. So this is video of the whole thing running. You can see like the light is dripping down the pipe and then further down, and it goes through the pumping station where it gets like macerated. So all those colorful things now become one thing, and then it drips down, and you can see like drips going down from the pipe to show stuff actually bottom, and drips going down the biosolids thickener. So it's showing the direction of the flow of these. And then, so this was just me experimenting partway through the process. How do I make this go away?
Is the trash can up a little bit above, like down?
There it is. Yep. Here, all down. So there we go. Okay, we'll just do that. So then I started experimenting with the diffusing treatments, and what I found over there was a TV had been disassembled, and there was a diffuser panel from the TV, and it was like a 55-inch TV, which was perfectly sized for this. So I ended up taking that panel, and I had to make a whole bunch of holes in it so that it would fit in place, but that became the primary diffuser for the whole thing, which was really convenient. But I did have to think about and experiment with the depth that the LEDs were offset from the diffuser panel, because if I wasn't careful with it, then the LEDs might like dip in, and then they would be too close, and you can actually see the pixels in the far left tank, the middle far left, but you can't see them on the grit chamber, which is the upper one. So I had to put in a whole bunch of spacers in between that diffuser panel and the electronics panel so that it would be a consistent depth and would look good.
This is also where I've got the 2x2 particle size rather than the 1x1, and it looks much better. So this is the space where it's going. It is the bathrooms on the first floor of the public market. And it's, yeah, they were painting. And so this is the kind of bathroom where there's no like gender. You just go into this common area. There's a sink that's right in the center console area, and then a whole bunch of rooms that have toilets behind there. And so as you walk into this restroom area, you'll see the sign very prominently, which is pretty cool. But it's also why it was important not to be this deep. I needed it to be more like 6 inches deep. So this is starting to put, like, I've removed all of the crap that was previously in there, and now I'm putting new stuff back in. So Chris was very helpful and used the color printer for the large format sections, text areas. And I used some vinyl sticker material to print the gels that would be in the front of the tank. And then I used a regular printer to print the for some more diffusion on the back of the tank. So the idea was there's ink on the front of the tank and ink on the back of the tank to give the whole tank some dimension. So there's like particles on the front and the back, and the LEDs to give a lot of depth. So yeah, this is the process where I'm putting everything back together. And then this is the diffuser panel that came off of the TV, with all of the spacers throughout and some holes for the mounting posts that the electronics panel sits on. And this is the electronics panel again. And now it's bolted into place. So it's sign, diffuser, electronics. And testing it out to make sure it all works. It was shortly after this that there was an inexplicable pop, and all of a sudden, and this was Friday, and the light stopped working, and there was a spark next to a wire that had turned black, and I was delivering yesterday, so there was some stress. Fortunately, it turned out that the component that had fried was that buffer. So I didn't need to replace a whole bunch of strips. I didn't need to replace the teensy. I didn't need to replace the power supply. It was just that one component. So that was handy. And oh, the old sign also didn't have backlighting on the big text areas. And so I added that because it would look cool. The weird thing is that the original sign did have diffusing paper behind those panels. So it looked like it was intended to be backlit, but there was no mechanism for it to be backlit. So I just added it. So here you can see the depth that I'm talking about with the gel in front and then paper behind it. And oh, so I gave a present to whoever maintains this in the future. I made a document that outlines like what I did. Some of the slides that are in here are in that document. My contact information, and a bunch of the spare parts that I used, so that if maintenance needs to be done in 20 years, you have the parts to do it. So it'll probably be me, but future Bob will be like, damn, past Bob was awesome. And that little package is like nestled in the sign. So as soon as I take it apart, it'll all be there. Thank you, Pascal. So this is installed. Well, not installed. Someone else is going to do the actual hanging of the sign, but this is now in the correct location. And will this video work? Start over because at the very beginning, like you can see the lights turn on in the home office and factory, and then the material flows up to the pumping station, and the pumping station motor turns on, and then each of these pipes and tanks fills as the water goes through the process. And so you can see, like, in some cases, things are floating down, and in other cases, bubbles are rising up. And over the feeding stream, which is down here, the water seems to be flowing, or the bubbles are flowing to the side. So yeah, it's all working. Very happy with it working, and that I can be done with it.
We got questions for Bob?
Yes.
The buffer to move up, is that, you confident? Done or?
So the place where the smoke happened was on the AC line that goes to one of the motors. And so what I think happened is that AC line touched something on one of the lines that feeds all of the LEDs. And so that fed things back up to the buffer and protected the teensy. So, because I knew, like, when I powered it back on, the code was still running. Like the relays were still working. They just wouldn't turn on the LEDs. So my worry was that either the buffer was blown, or the teensy GPIOs were blown, or the LED strips were blown. And that third option would have been catastrophic because replacing all of those strands would have been just a nightmare in 2 days. But fortunately, it was the buffer that was the easiest one to fix. But to answer your question, now every piece of AC is wire wrapped, like with a substantial amount of electrical tape. Yes.
How is it mounted to the wall? Would it be serviceable easily? Or is it...
So that's not my problem.
It's your problem.
No, I'm not going to be the one doing it.
Someone
else will do it. And my understanding is that it will either be French cleated, or mounted on a pedestal, or both. But the plywood that is the back panel is inset by 1/2 inch. So there's plenty of room for the French cleat or whatever attachment mechanism without having anything visible behind it. Yes.
I'm wondering, you said you wanted this to last for a little time. What happens, how easy would it be to update the content?
So if you take it, you have to take it off of the wall. And then there are 8 bolts holding the back panel on. And after you take that off, then the 3 panels of text content are just, I used acid-free single-sided tape to attach it around the borders. So you just remove the tape and print off a new one and tape it back on.
Post it on the front of the population.
Yes, right. Yes.
So now that we've delivered it, can the public market open?
I was been holding up the whole time. I don't know if you guys realize this.
Right. Yeah, I was the reason.
I think we're supposed to open less.
It's been supposed to open many times now.
Yeah.
Anybody else? Questions for Bob? All right.
Still not open. Where is the public market located?
Oh, if you, do you know where Mint Mark is?
Where's it?
Mint Mark?
No.
It's
Old
on
City
First and
Oh.
maintenance building.
It just says Baxter, yeah.
First one, John's.
Alright, I just got a quick update though there, but this will fall apart if you pick it up, which I don't care, but you'll feel bad because then you're gonna want to put it back together again. This is a cutout on the metal cutting fiber laser. Thanks to a nice donation from Isthmus Engineering. Got a bunch of stainless steel. And yeah, figured, you know, most useful thing you can do with it is to make a T-Rex, obviously. But so we bought a fiber laser cutter a little while back, and one of the challenges of the fiber laser is you have to align the beam in the middle of the nozzle. So on here you can see where the nozzle's at, and then there's a red guide laser that follows down the fiber optic with the like powerful laser, but it's not turned on when the other laser's firing. So at any rate, they have this fancy tool that you can see where the red dot is and see where the cone is, the tip. It's about like 2 millimeters in diameter. And then the tool will help you line up the red laser in the middle of the cone. Because if you shoot the cone, it's made out of copper, it'll just cut the cone, which is bad. So you don't want to cut through the laser tip, you want to have the laser go in the middle. The downside is they kind of want like a lot of money for one of these for some reason. So great in concept. So consequently what people do is they put Scotch tape on the tip of the laser, then you turn off the gas that's supposed to protect the lens, and you fire the laser through the Scotch tape and vaporize the Scotch tape, and then stick all the Scotch tape residue to your lens that's supposed to be really clean. And so every time you put a new anything in there, you're supposed to do that, which then messes up your optics that you just put in, which made no sense to me. So I went and looked around and I found a hell of a deal. $100 cheaper you can get the same thing. So that was totally unreasonable. I happened to be at an optics, what turned out to be more or less an optics conference. It was a conference on open source hardware at UW, but it turns out there's a ton of microscopy nerds at UW doing optics stuff. And so they had a guy whose name was Paul French in from the UK, and he was giving a ton of discussion on really deep, like super complicated optics stuff. And I, of course, had a question. You know, I told Paul, we got this thing, it's like $1,000, and it's got a red laser, and I want to look at the red laser of the camera. Am I going to hurt a camera if I just look at the red laser? And he's like, really? This is the question you're going to ask? No, you're not going to hurt the camera. So inspired by that, I decided to take a microscope and aim it at the red laser. And it indeed did not hurt the camera as promised by Paul, which was nice. But you couldn't see jack shit because the light is way too bright. So we needed to figure out a way to get the red laser not so bright, but still be able to see everything else, which is the trick that they're selling you for $1,000 is making that work. So we had somebody had donated a while back a little microscope camera, so I grabbed that. That's what I was testing with. And so we also had some filters around over the years, and so I grabbed some filters to try those and tried that out. And after a couple of filters, I got a filter that would work. So I nuked like $120 in filter things, playing around with this to figure it out. But we were able to get a little tiny red spot in the middle of a blue field. So like I said, this is about 1.2 millimeters across. So this looks huge, but it's really pretty small. And that red laser is about 1/10 of a millimeter. So it's really teeny tiny. So when you try to stick Scotch tape over it, it's really hard to interpret 1/10 of a millimeter on a piece of Scotch tape. It doesn't work very well. So I'm dealing with people who are buying metal cutting lasers as like metal fabricators. No offense, Tim. But they are not the most sophisticated software people. So this laser guide thing that they sell has like a bunch of software, a bunch of crap, and you're supposed to like care for it and be nice to it for $1,000. And I knew that wasn't going to sell very well, so I decided that I would just take a little coaxial, like a concentric bunch of rings and a piece of acrylic, and just stick it on top of the computer monitor. Super easy to explain to a welder fabricator. Take round things, stick it on your monitor and look at it, or tip your monitor on its back and set it on top of it and have a look. Rather than trying to say like, oh, launch the software thing and get OpenCV to run and all sorts of shit. This is just way, way easier. So I did that, worked actually pretty well. This is just cut out of acrylic. And so ultimately it looks just like a microscope camera with a little tiny filter sitting on top. Get a good image. And then I stuck a magnet on the back of it. And then we've got a very important optics protection system known as a plastic bag. And that actually worked out pretty good. So let's see here. So consequently, that allowed me then to do very important work, like cutting out a T-Rex. So I made a little T-Rex. It took a little convincing. This is a 3D printed model that I then used OpenSCAD to slice a plane out of it to turn it into a 2D DXF, and then cut it on a laser, and it doesn't really line up. So I'd use the press to smash some pieces together. So I thought that's pretty awesome. It came together, it worked, but I want to make a really big one. And so I dug around to see what kind of scrap I had laying around, and my scrap was a bunch of panels like this. And so I took these panels and I rescaled the biggest thing to fit across the biggest panel that I had handy. And so I laid that out. The downside is because I'm now using thin sheet metal with a big thing, I can't just scale it. I have to redraw all of it. So I had to go in and add new cuts to all these parts in order to get the width right to make it slide together nicely. I could have just said screw it and boogered a bunch of weld on there, but that's actually more work. So this was simpler to do. So then I made the one that's out by the front door to try to figure out how well it would scale. It turns out that's kind of the upper limit to that thickness sheet metal. It's pretty wiggly. Like when the wind's blowing, it's like waving away. So lifelike, that's what you call that. But the eventual goal is I'm going to try to make one taller than I am. Probably not as tall as Sean, but tall enough. So at any rate, that is the T-Rex. We're of course giving people a smoking deal for only $40. You can go on eBay and you can buy a filter from us to make your laser camera visible. So posted that today. We sold a couple of them. Hopefully they're useful for people, but it's certainly a lot cheaper than $1,000. So yeah. So if you got a fiber laser kicking around your house, you can go buy one of these and you'll be able to align it much nicer. Anybody got any questions? No, the T-Rex is not for sale.
So how big is a real T-Rex?
Oh, come on now. I don't know. So we'll start 3D printing it. It's fine.
The Scotch tape trick, they were sticking that over the cone, blasting one
The main, yeah, using the real laser to fire through the Scotch tape.
But that cut a tenth of a millimeter hole.
Yeah, then you peel it off and you look at it and you hope that you didn't like turn it a little bit while you're doing that.
You have the impression of the outside of the
Yeah, so you smush it in there and the ring has a little bit of soot, or the nozzle has a little soot on it. So you can kind of see where the thing was squished. But it's kind of like reading tea leaves, you know. If you're young and you got good eyesight, you'll do good. And if you're old, then you have no chance. So
curious, you sold 5 of them. What was the casting on getting? That sounds like a pretty good uptake in the day.
yeah, we had about 70 views. There's the laser that we bought is from GE. GE is a Chinese manufacturer of these lasers. They sell CO2 lasers. We bought a CO2 laser from about 13 years ago, and then bought this fiber laser from them 6 months ago. And they have a Facebook group, and they're continually incentivizing people to join the Facebook group because they're supposedly giving away lasers. I've never seen them actually give away the laser. I've seen them post that you can win a laser if you join the Facebook group, but I've never seen that. So there's like 16,000 people in the Facebook group. I have no idea how many people actually own these things. But essentially 70 of them were motivated to click the link today to look, because I posted actually yesterday an update of like, hey, if you want to do this, here's what you got to do.
How much 10 gauge do you need for your T-Rex?
The bigger pieces is going to be the problem. That's the tough part. You don't want to look at stainless steel pricing right now. It's very expensive. We'll be welding. Yeah, I know. We'll be welding pieces together, needless to say, to make bigger pieces. But I do have some bigger chunks of steel and I'll probably end up having to weld pieces together. But I do have to make it safe. So the other things, like that one, not going to be safe at reasonable scale. But I'm thinking I'm probably just going to end up trussing it, like either putting pieces together or redesigning it to make it smarter. But I did run across all of the old wooden dinosaur models are online. So I might try some other designs too and see if a Velociraptor is a little easier to construct because it's smaller pieces. So then I can make bigger small pieces. So we'll see.
So when you were doing the alignment, is it like blast and then adjust and then blast and then adjust? Or is this like a live thing where you can watch the camera image and make the adjustments?
Yeah, I should have better explained this part. So the fiber laser is kind of cool in that you've got this power supply. In the power supply is the big 1200 watt laser and then also the red laser. They both come through collinear through the fiber source coming over the laser. So then they've got a little handheld gun. On the gun, there's a whole lot of optics, unlike the CO2 laser, where there's like one mirror and you got to move it around. So that red laser is perfectly collinear with the big laser. And so, yeah, you put the camera underneath it, you're looking visually at the red laser, and then there's just 2 screws. And the 2 screws can sweep a plane, you can put the beam anywhere you want. So it's really easy to adjust. Unlike the CO2 laser, you got to start way back and then go through 3 mirrors to get to the tip. This, you just turn a little screwdriver and you can adjust the beam anywhere.
So basically, if the red laser is aligned, the real laser is.
Yeah, because you cannot fire the real laser into the. Well, you could once. You could fire the real laser, but yeah, it would not work after that. So you get one alignment out of the camera.
Right, but with the Scotch tape method, you have to use the real laser, which means you do it and then you have to turn off the laser and then make the adjustments. So it's not.
You just keep one eye closed while you're doing it, and it's not a big deal. But yes, you do have to fire the big laser while you got Scotch tape over the end of it. And then look at the Scotch tape, make a tweak, fire it again, look at the Scotch tape. So it's not like one time you're going to contaminate the optics. You're like firing this thing. I don't know, depends on how good you are, how lucky you are, but it's a pretty small sweep. And again, you're putting a 0.1 millimeter thing over a 1.2 or a 2 millimeter field. So yeah, it just felt like a really dumb thing not to try to pursue. So this made a lot of sense just to figure out what they're doing.
Did you actually have to adjust the laser?
I did a little bit. Yeah, it came factory out of adjustment. So yeah, lovely. It was a little bit, it wasn't bad, but it was definitely a little bit off. There's one other method that I haven't cross-checked to see. You could conceptually you could count turns on the screw. So there's 2 screws, and so if you sweep it all the way to one side until it gets occluded by the nozzle. So essentially, if the nozzle's here and you sweep the beam to this edge, we can then count turns to sweep the beam to this edge. Then you should be able to just divide in half and move to the middle. And I haven't checked that to see if your nozzle's round and you go to one edge and the other edge and then count to get back to the middle, you should be able to get it pretty damn close to center without needing Scotch tape or anything. But it would take longer because you've got to go way out of whack and then way across to get lined back up again. So who knows? I'm here to talk about T-Rexes, not laser lines. I know where you guys are off on this. Any other questions? All right, cool. That's all we got for presentations. So I'm gonna say who we are or what you're interested in. We'll score on the room. Take it away.
David Klon, been a member for a few months and I have a lot of miscellaneous interests. That's why I'm here.